I'm giving, I'm, I'm grouping that particular thing. At least through this diagram, please put effort and try to understand. So let the initial charge be Q naught minus Q naught. Did they switch? All are having same capacitance. No, I'll close the switch. So finally, what will be the charge on capacitor A Q naught, so that the final charge on A will be 5 microcoulomb. So
the polarity.
anything you can assume.
No, the final one also.
Final one you assume it. If you get negative charge, change direction, finish, or no second thought. Why you are wasting time in that?
No, sir, final one. In this we can change. Like if we get Q naught negative, we can change.
Final
With the
also, final also you assume it
okay.
simply. Look at this capacitor. What about this capacitor? What shall I do with this? If they're shorted, no, I should replace with a wire. So this will be a shorted one. This capacitor will be shorted. Okay, these two are yellow color. Let it be like this. We have, so finally, what should be the charge? The thing is, this was switch open. Now that the switch which was there here, it is closed. So I'm going to proceed like this. The charges in the circuit, let it be Q1 minus Q1. And here the charge will branch, no? Q2 minus Q2, Q3 minus Q3. They are in series, Q3 minus Q3. This I'm not sure. So I'll write it, this one. So these are the charges. Green color plates, red color plates, blue color plates, yellow color plates. Apply the conservation of charge everywhere. Write loop equation, solve, you'll get the answer. This very good problem I just specifically picked up to explain that one. So this is the A, there's a plate capacitor here. So we'll do one thing. So A, I'll write it. B, C I cannot use. D, E. These are the symbols. So at A, you write conservation of charge principle. At B, at D, at T, then write loop equation, solve it. How many unknowns are there? Q1, Q2, Q3, Q4. 4 equations, 4 unknown. We do get answer, but the conservation of charge at isolated junction must be applied properly. Hi, at B, okay, fine. This is a B, no? Okay, now I'll start with at A. What was earlier charge? What are A? A is here. Huh? This is A I'm taking. This is B. This is D, and this is E. So at A, look at that one. So what was the charge? Minus Q naught and 0. 0 should be equal to minus Q1 plus Q4. So Q naught equal to Q1 plus Q4. Now at B, what was earlier charge? Plus Q naught plus 0 plus 0. Q naught, you see that one, Q naught, green color plates. Huh? Still if you're finding difficult, it's a green color plate. So I think I can.
Sir, it should be minus Q.
plus which one? Okay, fine. No.
Minus Q4, sir. Q0 equal Q0 equal to Q1 minus Q.
This one. Minus Q1. I think I missed the sign. Now at B plus Q0 0 0. This should be equal to plus Q1 plus Q2 plus Q3. So Q0 equal to Q1 plus Q2 plus Q3. Similarly, at C, at D. And this is a shorted no this capacitor. So just replace with a wire itself. At D, what was earlier charge? 0 minus Q3 plus Q3. I think this will be no use. Just leave it here. Now at E, earlier the charge was 0. 0, or we'll write like this: 0 plus 0 plus 0 equal to finally Q minus Q2 minus Q3 plus Q4, or Q2 plus, so the equation 2. This is of no use, just leave it. Equation. So we need one more. So write any loop equation. So Q1 by C minus Q2 by C minus Q4 by C equal to 0. If you want, you write one more here. These two are in series, same charge, plus Q2 by C. I think when here one very good relationship between Q3 and Q2 will get it. Look at this loop here. The traversing of loop minus Q3 by C minus Q3 by C plus Q2 by C. Solving this, Q2 is equal to I think slowly we can get all the things. No? What is the condition? What is given for us? Q1 is given how much? 5 microcoulomb. So this is what the Q1, no? What we assumed it. Given is what? And given is, I'll write it. Okay, no. So substitute first value of Q1 in where all Q0. So we should get the value of Q0 here. I think this 1, 2, 3, 4, 5, this will be sufficient. And more of Q1, we know it. 5 microcoulomb. Solving, we'll get the answer 8 microcoulombs. So solve it later on. There's no problem with the data. Everything is fine. I checked it. This is like charged capacitor. This type of numerical not in advance. So why I picked up is like one charge capacitor. Usually we did very simple cases, no, like a series, parallel. Now one charged capacitor can energize a group of charged capacitor or a network itself. So there the charge at isolated junction alone will help us here. So you should not do mistakes like this. So like here charge will flow. So Q1 equal to here same charge I'll put it. I think these are some mistakes what students will do. You must give priority for charge at isolated junction. It's a very good problem. Those who are still finding difficult, no, just do learn at least from this.